Okay folks, so in the last video we left off and we were determining the length of this third side of the triangle. You can see that I've kind of cleaned up the drawing a little bit. That worked out to 963.6 feet. That's not particularly relevant unless I guess you wanted to maybe throw some object and try and hit the tip of this pyramid, but it doesn't help you solve the problem that's been stated to you. We've already solved the first part of the problem, which was the slant height of this, 554.6 feet, which agrees with the answer key given at the end of the assignment. Now, the remaining piece of this is to determine the vertical height and width of this tower. Well, the vertical height is perpendicular, and it's specifically a perpendicular bisector of the width, which just means it splits this thing right down the middle. And again, that's a property of this being a symmetrical pyramid. Well, what do we know? We know that this angle here is the complement to this angle that's given over here in the problem. So again, 52 minutes would get you to 43 degrees, and then 43 plus 47 gets you to 90. So this is 47 degrees, 52 minutes. This angle is 90 degrees just because by definition that which is plumb is perpendicular to that which is level. And so we actually don't even really need to find this angle, but we could find it by adding 90 to 47 degrees 53 minutes and subtracting it from 90. Now we're trying to find this height. And so if you think about this angle that we know to be 47 degrees 53 minutes, we know the hypotenuse. So now we're dealing with a right triangle, so the regular sine functions will work. We know the hypotenuse of this triangle, and we know the side opposite of the angle. So we have to think about a function that relates the side opposite and the hypotenuse. So if you remember SOHCAHTOA, we see that it is the sine function that relates the opposite and the hypotenuse. So again, the way you would solve this part of the problem would be sine of 47 degrees 53 minutes. Let's put it in decimal form so the calculator can deal with it. So again, the way you go from degrees, minutes, seconds to decimal degrees is you take the fractional part, so 53 minutes divided by 60, plus the whole part, 47. So we see that this is about 47.883 degrees. So we take the sine of 47.883 degrees. And what is that equal to? It's equal to the opposite, which in this case is the height. So the opposite side divided by the hypotenuse, but we already know the hypotenuse to be 554.6 feet. Now the question is, how do you get the O, the opposite, by itself? Well, you multiply both sides by the denominator. So 554.6 feet times, and let's calculate what the sine of that number is. So again, pull up the calculator, clear out of everything, make sure we're in degrees mode. 47.883. Take the sine function, and that's 0.742 approximately. So times 0.742, that's going to equal the height of this pyramid. So, I mean, just in round numbers, it's about 3/4 of 550. Well, 3/4 of 600 is 450, so it's going to be somewhat less than 450, just as a ballpark. So let's just take this times 554.6, and about 411 feet, 411.4 feet by the looks of it. Seems reasonable. Now, of course, you know, if you got a number like 4,000 feet or a number like 4 feet, you would you'd question the validity of your calculation, but this seems reasonable. 411.4 feet. Now the last part of the problem asks us to determine this width. Well, again, now we know the hypotenuse of the triangle and one of the other sides. But if you think about this height was a calculation based on a calculation. So It's probably a little bit purer to use the hypotenuse and the angle to calculate the length from one side, from one vertex to the center of this span, to this perpendicular bisector. So we got to now relate hypotenuse and the adjacent side. So we come back up and we look at SOHCAHTOA, and oh, there it is. Cosine relates adjacent and hypotenuse. So the way we solve for that is cosine of 47.883 degrees equals, what does it equal? It equals the adjacent side, which we're trying to find, over that hypotenuse, which we've determined to be 554.6 feet. The process is exactly the same. We multiply both sides by the length of the hypotenuse, 554.6, by whatever the cosine of 47.883 degrees is. Now, as you get familiar with the trig functions, you're going to start kind of being able to guess at these. So one thing I know is that this is less than 90 degrees, so cosine is going to be positive. And I think the cosine is going to be awfully close to the square root of 2. So I'm going to guess right around 1.4. And that is purely a product of having done this a lot. You start to be able to guess kind of what are reasonable outputs. So you see I made a mistake there. I hit the sign key and the number didn't match our expectation. Let's try that again. 47.883. Coming over here to the cosine. Okay, so 0.67. Yep, that does actually make some sense, because the square root of 2 is not the cosine of 45 degrees. The cosine of 45 degrees, I think, is the square root of 2 divided by 3, and that would make some sense there. So 554.6 times 0.671, 671, and that's going to equal this length of this side adjacent, which is going to equal, let's pull it up on our calculator. So we're going to multiply this times 554.6, about 371 feet. 371.9. Just shy of 372 feet. Now, what you have to keep in mind is that's only half the width, right? That's only from here out to here, so 371.9. Of course, the way we get the entire width is we simply double that. And again, that's a product of the fact that this is a symmetrical pyramid. If you take away that symmetrical rule, a lot of these assumptions we're making fall apart. So, about 743.9 for the entire width. And you have to ask yourself, is that a reasonable number just looking at the picture? Well, yeah, it probably is, given that this thing's got a height of 400 and change feet, and it's maybe not quite twice as wide as it is tall. All of these numbers are reasonable. So this is just a good illustration how you can use the regular trig functions if you can create a right triangle for yourself, and then law of sines or law of cosines if you have this triangle that is not a right triangle. It took a little bit of calculation, but if you keep working on problems like this, you can almost always figure out missing parameters.